Vertical upward motion, problem number 14. What is the original vertical velocity of a ball thrown over a tree 15 meters tall? And how long is in the air? So this problem is asking two questions. One is the initial vertical velocity and how long the ball stays in the air. So let's illustrate this problem by drawing a very tall, skinny tree. So you can understand a little bit the concept behind all this. So here we have a ball that is going to be thrown over this tree. So we have a symmetry. So this is on the top of the tree. The ball is going to stop and then it's going to change direction. So it's asking the initial velocity going up. Again, when we have a problem like this, you have to look on two ways. One is going up and one is coming down. So there are two different things going on here. When it's going up, it's going to be thrown with a velocity that is greater than 0. It's going to decelerate until it gets 0. And when it gets 0, it's going to change direction, starting from 0, and then it's going to gain speed as it starts to come down. So we need to pick one side that we are going to be working with, because the symmetry of this problem is going to give us the time that is taking to go up is the same time that is going to take to come down with the same reference. We have more information as is going up than is coming down. And the way that we are going to do this is by drawing this diagram. This table. So we have here VI, VF, DAT. So our initial velocity, that's what we are looking for. This table is going up. The final velocity is 0. The distance is how tall is the tree. Notice I'm not going to double because I'm doing just one side. So is 15 meters. The acceleration, because it's decelerating, so it's negative 9.8 meters per second. And I don't have this information here. Time up. Okay, so let's first find VI. So then we are going to look our equations, and the selection that you are going to make will be based on the information that we have. We don't have time, but you have a distance, and you are looking for VI. So this equation number 3 will be perfect to find VI. So let's use this equation. So VF squared is equal VI squared plus 2AD. My VF is 0. My VI, that's what I'm looking for. And 2 times negative 9.8 times the distance, which is 15. So let's rearrange this. 0 is VI squared. So we are multiplying here 3 numbers, 2 times 9.8 times 15. And 9.8 is negative. So then we have a negative number here. Now 2 times 9.8 times 15 is 294. So 294, and we are going to add both sides, 294 plus 294, and those two cancel. So VI squared is equal to 294. Now we are doing square root. So there will be square root of this is 17. So VI squared is equal 17.1. VI is 17.1 meters per second, not square, as I already square root. Okay, so now our next step will be find the time that was in the air. So for that reason, you need to find time up. Now again, we have to look which equation we can use that can give us the time up. Looks like the first one will be the perfect equation. So let me draw a line right here. And second, find time up. We are using the first equation, VI plus AT. So our VF is 0, VI is 17.1. We have this value now. And because you are going up, so the acceleration is still negative. And this is T. So now we have 17.1 is equal negative 9.8 T. So T is 17.1 divided by 9.8. So 17.1 divided by 9.8 gives us a time going up of 1.74. Let's put this way, 1.74 seconds. But the problem is asking the time in the air. So the time in the air is time up plus time down. So my time up is 1.74, and time down is the same value because time up and time down is the same because the symmetry of the trajectory. So time is in the air, time in the air. So that gives us the time in the air equal to 3.4 seconds. So this is one answer for this problem, and this is the other answer.